All pulley-driven fan clutches may be thought of as two components. One component that rotates with the pulley, called the drive portion, and the other half that independently rotates with the fan blade, called the driven or clutch portion. Some mechanism is used to get these two portions to rotate together in a coupled state. Once coupled, the fan blade rotates in the same speed as the pulley, and the fan clutch is engaged. This is true for on-off fan drives. With air-engaged fan clutches, it is air pressure driving the friction material into the fan plate. With spring-engaged fan clutches, it is spring pressure driving the friction material into the fan plate. An air-sensing viscous fan clutch replaces the spring, air, and friction combination with shear plates and viscous fluid to drive the two halves. Inside of the body of a viscous fan clutch, the drive portion and the clutch portion have shear plates. Shear plates are two independent plates that are lined with circular fins that interweave each other very closely but never actually touch, so there is no friction between the two halves. The center of the clutch has a reservoir which houses the silicone viscous fluid, a special fluid with a honey-like consistency which is designed to cause a shear force between the two halves. This shear force becomes the drive mechanism between the drive portion and the clutch portion. The air-sensing viscous drive fan clutch is a closed, self-contained system, which means it is not connected to a thermo switch, to the ECM, or to an airline. It is completely self-contained. At the front of the fan clutch is a bimetallic strip or coil, which is made up of two pieces of metal bonded together with drastically different thermo-expansion properties. Small temperature changes equal large dimensional changes in the length of the bimetallic strip. The strip is connected to an internal valve, and the change in length of the strip causes it to either open and release the viscous fluid, or to close and contain the fluid in the reservoir. When the ambient air temperature rises, the bimetallic strip or coil expands and the valve is opened. This releases the viscous fluid. Centrifugal force causes the fluid to flow to the outside of the clutch housing and into the shear plates. As the fluid passes through the shear plates, it causes a shear action between the two portions, essentially filling the space between the shear plates, and a drag is created from the drive portion to the clutch portion. This causes the fan to turn. As the fluid is centrifugally forced to the outer diameter of the fan clutch, the force causes the fluid to enter a small fluid path that returns it to the reservoir in the center of the clutch, where it is then once again forced toward the outside of the clutch. This pumping action continues as long as the reservoir valve remains open. When the ambient air temperature reduces, the bimetallic strip or coil contracts, causing the reservoir valve to close. As the fluid is pumped into the reservoir, it is now contained. With no fluid in the shear plates to cause drag, the fan clutch is disengaged.